Hi guys, Mr. Cox. This is the first of about 4 or so videos where we're going to look at some real key questions that tend to come up in exams year after year after year. So I'll do a few of them and talk to you awkwardly a few just to get a bit of a change of faces. So the way these videos are going to work, we're going to look at the question, we're going to sort of pick out sort of key details and sort of key information that if you're in the exam, hopefully you'd be sort of thinking about these things before you start to write your answer. Then I'll pause the video, give you some time to actually have a go at answer the question yourself, and then I will model how I'd have answered the question, and hopefully you can do better or if not as well as me. So, this question. I know it's not brilliant to see, but in a minute I will zoom in on a bit of paper and it'll be a bit easier to see. So, question is about bonding, covalent bonding. This question is about. It tells us the bonding in iodine is similar to the bonding in chlorine. Complete the diagram below to show the bonding in iodine. So, at this point, what have I already got? I've got these overlapping circles. That's hopefully probably tying me off. That's one of those types of dot cross diagrams. Okay. I've also been told that it's iodine. And I know some things about that, or I can find them out from the things I have in the exams. So iodine, I do know, if I look at my periodic table, I know it's a non-metal, which tells me it's going to be covalent bonding, hence that diagram looks like that to start with. I also know it's in group 7. And very importantly, if it's in group 7, that tells me that it has 7 electrons on the outer shell. And with that information, I have everything I need to be able to draw a dot cross diagram of iodine. Okay, so that's the first part of the question. That would be 2 marks. We then got another bit, so slightly longer style answer. Explain why iodine has a low melting point. So, tricky question this one. This is a classic one where people get wrong because they talk. I'm not going to tell you now, but they make some assumptions. But what do I know? So again, already we know iodine. We know from that picture up there that it is covalently bonded. Okay? And nearly all covalent chemicals have low melting and boiling points. So I know it's covalent, and if you understand covalent bonding and how the particles, when they're covalent bonded, interact with other particles, that question is not too bad. But that is a difficult question most years. And lastly, we've got a question here. Explain in terms of particles why liquid iodine does not conduct electricity. So again, both of these questions are to do with relating the type of bonding it has to the properties it has. Okay, so electricity, why does it not conduct? Well, one of the things that should be jumping in my brain at this point is electricity. To have electricity, you need a flow of charged particles. Okay, so really the question is, why don't I, with iodine, have charged particles that can flow? Okay, so that's the setup of the question. We've got, what, in total 7 marks. So in a real exam, you'd have about 7 minutes. So maybe pause the video, give yourself about 7 minutes, see how you do, and then I'll talk you through my answer. Cheers, guys. Okay, so how would I have answered this question? So, good old-fashioned bit of paper in front of me, we'll do this old school. So, let's have a look. Tells me to only show the outer electrons. Things I already know, it's in group 7. Okay, so that's telling me there are 7 electrons in the outer shell. So, with covalent bonding, what we need to think, they are trying to get to a full shell. A full shell would be 8. At the moment, each of those atoms only has 7. So, the way you have to work it out, you share as many as you need. So if you need 8 and you've got 7, you're 1 short, so you share 1. So this one on the left, I'm going to use crosses for, and I know it's going to put 1 in the middle. Okay, and they're a bit fussy. It shouldn't be on the lines. It should be in the middle. Okay, it's in group 7. It has 7 electrons in its outer shell, so the other 6 are still there because it must add up to 7. So 1, 2, 3, 4, 5, 6, and a total that's 7. Obviously, the other atom is going to do exactly the same. So of its 7, 1 will go in the shared section. The other 6 go elsewhere. And that is your complete dot cross diagram for iodine. So 7 crosses, 7 dots, and importantly, for each one there is 1 of each shared in the middle. So that's a single covalent bond. Okay, that would get you 2 marks. All right, second bit. Why does iodine have a low melting point? And we know it's covalent bonding. Okay, so that's just a little note to myself. So, what does this mean? If it's got a low melting point, then it must be the case that the bonds between those particles, I'm being a bit careful about how I say this because I don't want to get you, must be weak. But which bonds am I talking about? Okay, so I'm just going to draw a little picture up here as just a little bit of extra. So think about iodine. I've got an iodine molecule there, so two iodines stuck together, and I might have another one over here, another one over there, for instance. Okay, they're covalently bonded. The forces between them are what we need to overcome in order to melt this thing. Okay, and those are a lot weaker. So what am I going to say in my answer here? Why has it got a low melting point? So in my answer, I would say iodine is a simple covalent molecule. So it's made of small molecules. Okay. Between the molecules are inter, meaning between, molecular, molecules, forces. And I've gone off the line here, ignore me. Oh, that's not very well focused, is it? A little bit better? You might know. Try that. Okay, so iodine is a simple covalent molecule between intermolecular forces. All I then need to say is those forces are quite weak. And so little energy is needed to overcome them. So your key 3 points really, it's a simple covalent molecule, intermolecular forces are between the molecules, and they're quite weak, you don't need much energy to break them. That would get you 3 points. Okay, the final bit of the question then. Explains in terms of particles why liquid iodine does not conduct electricity. Okay, so one of the key things I already know is it's covalent. Okay, so covalent molecules on the whole do not conduct electricity. There are some rare examples like graphite, but simple covalent molecules on the whole don't conduct electricity. So, why not? This question is actually quite simple and it's asking us to explain that. For you to conduct electricity, you need charged particles that can move. Now, iodine is a liquid, so all the particles in there can move, so that's a good sign. However, they are not charged. Because each iodine molecule is neutral, there's no charged particles moving around. So that really is the crux of my answer. So, all I'm going to say is, why doesn't a liquid not conduct electricity? I'm going to say iodine is made up of covalent molecules, probably giving more detail than I need here. They do not have charged particles that are free to move, and those charged particles are going to be either electrons or ions. Doesn't have either of those. And if you haven't got those things, what you do, so that'll get you 1 mark by just, and I've written more than you need to, I could probably just said it doesn't have any free electrons. That would have probably covered the first mark, but I've said made up of covalent molecules, they don't have any charged particles that are free to move, which would be electrons or ions. Okay, if you don't have those things, the thing you cannot do, it therefore cannot conduct charge. Actually, rather than conduct, I should probably just say carry charge. So there's your final bit of your answer. The 2 key points in there: it doesn't have free electrons or ions, and therefore can't conduct or carry charge. So quite a simple answer, really. We've gone through the whole question now, so that's all 7 marks. Hopefully you've looked at yours and you're thinking, yeah, I'd have got most of those, which is good. As I say, I'll do a few more of these videos covering some other sort of key questions that tend to come up in C1 and C2 in real exams. So thanks for your time, guys. Have a lovely day. Bye now.